So if you, and I know there's like fast testing, all kinds of stuff going on right now. So if you happen to miss either day of those classes for whatever reason, just know Thursday and Friday are makeup days. So whatever you miss, you'll make up on those days, okay? So we can get everything done before the end of the week. All right. Starting with number 7, and if you're doing this with me, as I hope you are, make sure you clear your RAM. You guys do that every time. Just do it, do it, do it. So number 7, suppose you invest $3,000 in an account that pays this percentage compounded continuously, and they give you everything plugged in, okay? What it's asking for is to determine how many years, so that's T, time, that's what we're trying to find, to make the investment double. The investment is your P value, so we want to see how long it will take to make $6,000, okay? So we're going to take that doubling. Oops, there's another 0 in there. 3,000 e to the 0.05252. And we're going to solve this equation algebraically. And then when we get to number 11, I'll show you how you could have done this one in your graphing calculator too. There's 2 different ways you can do it, and either way would be totally fine. Okay, so here's the algebraic way, which is to solve for t. So first thing I'm going to do is notice that this is an exponential function with a base e. When in doubt on how to start pretty much every problem, I can't even think of a time I wouldn't even say always. If you don't know how to start a problem, think about getting the base by itself. That's usually going to be your first step. Or in a log equation, get your log base, whatever, and its number by itself. And you'll see me do that like 5 times today. So I'm going to divide both sides by 3,000, which gives me 2. And so whenever we're solving exponential functions, one way we've done it is to get like bases, but you can't make a 2 into an e or an e into a 2. So another way of doing it is to rewrite it in log form. So what we do to write something in log form is we write log and then the base. Now, because our base is an e, instead of using log, I'll use ln, okay? Just because that's an e, which means we have a base e, which we don't normally write, but I'm just going to go ahead and put it there in case you need it. Our exponent gets its own side, and then that 2 would just go right here. So writing an exponential in log form is a way of getting the t on the ground so you can solve for t. And then the last step, before I put it in my calculator, remember I'm trying to get t by itself, so I would divide both sides, 0.0525, divide both sides. And you don't have to show work, okay? So you could get to whatever step and then pick up your calculator. So at this step, I would put in natural log 2. Notice the parentheses are open. I want to close them before I divide by 0.0525. And you get an answer of 13.203. And when you go to answer that, as far as which choice it is, I'm sure we could agree that we would narrow it down to A or C. And the common mistake is to think, oh, I know, 2 rounds down. We would stay at 13. But remember, in a real-life problem, you can't just go by typical rounding rules. After 13 years, we haven't paid off the loan, right? After 13 years, there's still this much of a year's worth of a payment. So this would be 14 years, okay? So be careful on that. Number 8 is the only question on the entire test, multiple choice part of the test, where you have to show work for credit. And it's asking for the inverse, and then use limit notation to describe the end behavior of the inverse. So inverse means switch x and y. I mean, I say it so many times in this unit. I'm going to say it so many times today. There's so many times on this test where you have to switch x and y. So that's where I'm going to start. So I switch x and y, and then I'm going to solve for y. So remember, if you are in a place where you just don't know how to start, a good place to start is to get the log at its base and its number by itself. Just like I said up here, it's a good idea to get the base of an exponential by itself. So I have to get rid of this 2, so I would divide both sides by 2. Okay. And then I'm going to write this log in its other form. That's a way of getting y by itself. So base 2 to the power on the other side equals y minus 3. So I would have log base 2 of x over 2 Wait, what am I doing? Oh, sorry. What am I doing? I don't know why I wrote the word log. That's why I got lost. No, we're getting rid of the log. Base 2, 2 to the power of x over 2 equals y minus 3, right? 2 to the equals that. And then to get y by itself, I would add 3 to both sides. So this would be my inverse. Okay? Now, all that work to get credit, but we still haven't answered the question. Since it's a graphing calculator question, I'm going to put this in my graphing calculator and look at the picture. So when I go to y equals and type that in, 2 to the power of x over 2, move my cursor over, plus 3. And remember, you guys, you have to know how to put all this stuff in your calculator on the test. I cannot help you. I will not help you. You have to know. And then hit graph. Instead of messing with the window and really getting a good look at the picture, that should be enough to kind of tell you what is going on there. I said x times 2. I need to slow down and just relax. Okay. So what we should see is this, which is very similar to what we saw. And guys, remember, an exponential function, like just the parent function, is a j, okay, where your horizontal asymptote is at 0. So this plus 3 just moved it up 3. That's what we're seeing there, is all the points got moved up 3. That's telling you there's an asymptote there. So for our end behavior, as x increases, y increases, right? So as x goes towards positive infinity, so does y. And to the left, as x goes to negative infinity, y approaches 3. So that's why it would be this one right here, okay? Goes up on the right and goes towards 3 on the left. The asymptote stops it from going down any further, okay? And I don't need to see a drawing of it. I just need to see the work right there. Okay? Number 9. We're given an equation, beta, that's our Greek letter B, stands for level of sound in decibels, and it gives us this equation, 10 log, and then I is in the numerator, that's the intensity, and it gives us that. So I'm just going to plug it in. And then simplify it, okay? In my parentheses, I have like bases. So let's bring this other stuff down. So I have base 10 to the power of whatever our exponents are subtracted, right? That would be 7 minus 5, or 2. So this would be negative 5 minus negative 16. Negative 5 minus negative 16 would be 11. So keep your base, subtract your exponents, and then look at it carefully, guys. There's a base 10 right here. That cancels. Log 10 is 1. Log of 10 is just 1, because it's log base 10 of 10. And the 11 can come to the front because of the power property. And there's already a 10 there, so we multiply them. So 11 times 10 is 110. And that would be your answer. Okay. Number 10. Here's a function. What's the equation of the inverse? So switch x and y, solve for y. But there's a really easy way to do this problem. So 4, 2 right here, 4, 2 is a point on f of x, right? This is the graph of f of x. That's one of its points. So that means that for the inverse, you could flip those points, right? We know this. Inverse, flip anything that has to do with x and y. Domain, range, points on a graph, points in a table of values. So in our new function, this is a point. Meaning, if I plug in 2 for x, I should get 4 for y. So I'm going to just plug and chug, I call it. Plug x is 2 in for the problems until I get a y of 4. and it ends up being this one. So if I do 2 minus 2, so I just plugged the 2 in for x, that gives me e to the 0. Guys, don't forget, anything to the 0 power, a number or a letter, is 1. E to the 0 power is 1. So that's where I get y is 4. Okay? So just pick a nice point, flip it, plug in the x's, which one gives you the y value. Okay, number 11 is just like number 7, believe it or not, okay? Let me show you what I mean. They give us an equation, and they ask for x when price, or p, is 300, right? Same idea. So 300 is p. So we could do this problem the same way we did this problem. We could isolate the e to the power and then rewrite it as a natural log. This one's got a lot more going on. Subtract 450, divide by negative 0.4. It's all calculator work, so it's not impossible, and then you would go into all this. So you could totally do number 11 exactly like number 7. But I'm going to show you how to do it easier in your calculator, which is also a way you could do number 7. You could do this in your calculator there too. So you would want to clear your RAM. And guys, understand this. I think I started talking about it on Friday or Thursday or something, but if I gave you an equation, the intersection function of your graphing calculator, where you find the intersection, is solving an equation, okay? So if I put into my equation, which I'm not going to take the time to do, let me clear my RAM, but if I put 2x as one of these and 10 as the other. So each side of an equation gets its own y sub something. It doesn't matter which one goes first or which one second. When I go to find the intersection, guess what my x value would be? Yes, it would be 5, because that's the solution. So what intersection does is it solves really complicated equations for us, and that's all this is going to do. If we go to y1 or y2, it doesn't matter which goes where. I put 300 as one of them, and I put the other side of the equation. Nope, didn't mean to do that. 0 minus 0.4 e to the power of 0.008. Okay, so I type it and double check that you have enough zeros and everything's in the right place before so take your time with it on the test. And then I'm going to graph it in a second. But before I waste my time graphing it, I already know I told my calculator to go as high as 300. And if I go to my window, it's only as high as 10. So my x max, I have to change to something above 300. So I went 400. And these are all your solutions, right? These are the possible solutions. Our solution is one of these 4. These are your x values. So we're telling our calculator only to go out, whoops, I did that. Gosh, I'm sorry. Let me put that back. That should have been y max. Y max, how high up. Guys, keep an eye on me if you see me make a mistake. How high I go is 400. Sorry about that. And then these are my x values, and my x max is typically only at 10, right? That's what, when we clear our RAM, it only goes out to 10. Well, we want to make sure we find our solution, which is somewhere between 400 and 900. So maybe I'll go up to 900, so in case that's my solution, I'll be able to find it. Okay, so take into account what you need to change your window to. X max is to the right, Y max is up. Make sure when you hit graph that you can see your intersection. If you can't, you got to go fix your window, right? And then we hit second calc, and we're going to do number 5. And intersect is the easiest one. As long as you cleared your RAM ahead of time, you actually don't have to move your cursor at all. Your calculator will do all that work for you. You can hit enter, 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 and it'll give you your answer. So the solution to this equation, this would be the closest one. So you could have done the same exact method with this one, just so you know. If you didn't like that, you could have put 6,000 there, 3,000 times e to the blah, blah, blah there, changed your window, found your intersection, and you would have had x is 13.203. Either way, okay? And lastly, here's a graph of f of x. G of x is the inverse what is the maximum value of G? Guys, maximum, the word maximum means the largest Y value. Okay, we want to know the largest Y value of G of X. So a really simple way of doing it, whether you write it out or not, is to flip your points. Flip the points of f of x, that would give you your inverse, and then you can see the biggest Y value is 7. Okay? Good? So that's the multiple choice for the calculator portion. All right. Let us go to the FRQs. Let's do tomorrow's FRQ. Here's tomorrow's FRQ. All right, so guys, I would really pay attention here. These are a lot of work. These are bigger FRQs than we've had before. They're worth more points. And I'm going to tell you exactly what you have to give me to get all those points and what would not give you points. Okay? So we have a graph of an exponential function in this form. And the first question is, what is the C value? Now C, look where C is. We've called that K before, how high or how low the graph goes. That's what that number represents, how high or how low. So this is an exponential function. It's normally a J, but some transformations are happening. But we should know that C is how high or how low the graph goes. So C in this problem is -1. That's the lowest Y value, right? Now that's just this one point. To get the other point, you need to give me a reason. And there's one of two things you could do here. You could either say, because Y equals -1 is the horizontal asymptote. Okay. Or you could state, let me just use this, you could use a limit statement about what's happening to the right. Because remember, limit statements are sometimes called, or end behavior limit statements are sometimes called asymptote limit statements, because they will tell you what's happening with an asymptote. So as we go to the right, our graph is approaching -1. That means we have an asymptote at -1. So one or the other of those, you don't have to give me both, but one or the other needs to be given to get the full amount of points for this part. Couple different things you don't want to say. You wouldn't say because -1 is an asymptote. If there's more than one type of asymptote, think about that. How specific do I have to be? Well, if there's 2 asymptotes in this world that we talk about, well, we need to specify which one. Okay? So make sure you give me a valid reason. I gave you 2 of them right here. Pick one if you don't want to do both. Okay? Part B is probably the hardest that you're going to have to do, so let's talk about this. There's 3 parts to it. Do the third part first is my advice. It makes the other 2 a lot easier. And it says to use the point shown on the graph and find values A and B, and we also have to find the equation. Okay, so we also have to write the equation for doing that. So here's the thing. Here's our function, okay? There are 5 variables, g of x, a, b, x, c. 5 variables. All I actually have for sure is c. I know that c equals -1. But I also have a graph full of points, and that can get me x and y. Now, usually when there's 5 variables in an equation, we would have 4 of them. We would have 4 of the 5, so we can plug in the 4 and find the 5th. Well, here we're only going to have 3. The reason is, and this is going to be required on this kind of question by me, is to give you a nice, friendly point that contains a 0, okay? That's the point you will start with. It does matter in this problem because we don't have all the letters. And the reason why we want to use that point is this. So now when I plug everything into the function, y equals, I don't know a, I don't know b, and then I have to the power of 0, there's my x, and then there's my c. The reason why this will work, even though we have 2 variables, is b to the 0 is what? 1. Okay, so I have C and I have A now. I still need B. Now is when I can use any point different from that one. So maybe like 1 and 3. So if I use 1 and 3, there's where I have 4 of the 5 variables. So I can plug all of these in and get the B. But you could have used negative 2, 7. It doesn't matter at that stage what you use. Okay? I am shocked at people with their heads down and not paying attention to this. I'm giving you guys some really valuable information here. Okay, y equals a times b to the negative 1 minus c. And now I'm going to simplify it. I'm solving for b. I would add 1 first, divide by 2. And I got a lot of questions from you guys about how I did solve for b on my key, so I'll show it another way in case that helps you guys. So, guys, remember, I want to solve for b to the first power, not the negative first power. So a way to get rid of a negative exponent is to cross the fraction bar. So right now it's in the numerator. If I move b to the negative 1 to the denominator, it suddenly becomes b to the positive 1. Okay? So that's how I took care of the negative, but I still have to solve for b. So I'll multiply both sides by b. Remember, whenever you have a fraction, multiply by the denominator gets rid of the fraction. And then divide by 2, and b is 1/2. Now I have a, c, b, and I can write the final answer, which would be 2 times 1/2 to the power of x, right? In your final answer, we never plug x and y in. We've used those spots to help us find the other letters in this work, but we don't put an x or a y in our final answer, okay? So you're going to have a problem just like that. Now we can go back and answer 1 and 2. So listen, part 1 is asking, is a greater than 0 or less than 0? That's simply asking, is a positive or negative? A is clearly positive, okay? So a is greater than 0. You can answer it right here on the FRQ, right? A is greater than 0. And it's going to ask for you to give a reason. What is the reason? It's really, really simple, guys. If A is positive, that means there's no flip, okay? Right? Think about it. If A was negative, all these points would flip over the asymptote. So when A is greater than 0, it's because all points of g of x are above the horizontal asymptote. If A were negative, I would say because all points of g of x are below the h of a. That's simple, okay? Because that's what a negative a value does. It flips you over that. Flips you over the x-axis, and then the asymptote moved you a little bit. So you can just say over the asymptote. For part B, B is less than 1. I'm going to say it differently. Right? Between those two, B is in between 0 and 1. Why? Because the graph of g of x is decreasing. It's falling left to right. Yeah. Here's what you don't want to say. Here's what will not get you a point. Because it's decreasing. What's decreasing? The graph or the A-rock? Whenever there's a word that we use to describe more than one thing, you need to be specific. Just like asymptote, you have to tell me H or B. The graph is decreasing. Okay? Let me ask you this, guys. What if you had this? What if I took that same graph? This might be a hint here. What if you took that? I took that same graph and I flipped it. Let me think about this for a second. Just so you know, of course, A is less than 0 here, because all my points are below the asymptote, which in this case would be this. But you might have, so if you look at this graph, what would you guys say? Would you say this is increasing or decreasing? It's increasing, okay? But you have to judge increasing it or decreasing before a flip. Before this was a flip, guess what it was? It looked like that, right? Before it flipped over. That's actually what? Decreasing. And guess what? You would have already have done this part by itself. you would already have in this situation that b is between 1 and 0. You would already have that. For example, this graph right here could be this, the exact same thing we just had, but with the a value being negative. So a is less than 0. Why? Because all of your points of the graph are below your horizontal asymptote. But what is b? B is between 0 and 1, right? Like you would see that here. But it doesn't go with this. But you would still say because b is, what would I say here? Because the graph, let me say it right here. Because the graph is increasing, but a is less than 0. So when the a is less than 0, it's opposite. And we talked about that like for a blip of a moment, but you might want to go back and revisit that idea or kind of internalize this. It's in the video, so you could go back and look at it. So you might do all that work for part C correctly and then be questioning yourself on part 2 because B is less than 1, but it's increasing because there was a flip. So before the flip, it was decreasing. Okay, so that's something that could pop up. Don't know. All right, and last little bit of work on this one really is finding the inverse. So I'm going to switch x and y, solve for y. Understand, this is an exponential function. The inverse of an exponential function is a log. It is a log right now. Anytime y is an exponent, that means it's a log. But we want to clean it up and put it in log form. When in doubt, and you don't know what to do, get your base and the exponent by itself. Okay, so I'm going to add 1. Add 1 to both sides, and then divide by 2. So right now I have x plus 1 over 2 equals 1/2 to the power of y. Okay, write it in log form. How do we write something in log form? We start by writing the word log. How did I know to write log instead of ln? Because base is a number, right? If this was an e to the y, I would have written ln. That's the only difference between log and natural log. So log base is 1/2. Remember, your exponent always gets its own side, so y, and then all of this goes here. Are parentheses required? Yes, they are. You must put the parentheses here, okay? And y is already by itself. That is the inverse. That is the inverse. Exponential to log. Last part of this, domain and range. Really, really easy, guys. If you know the domain and range of this one, you just flip it, right? The domain of this graph is all real numbers, right? It goes from negative infinity to infinity. That means it's the range of this one. Flip it. The range of this graph would be negative 1 to infinity. Remember, least to greatest, negative 1 to infinity, so that would flip it here to this, right? Because there's no calculator. You can't put this in your calculator and look at the picture. Use what you have. You know that these are inverses of each other, and you guys have been doing a really good job with doing domain and range. So if you know domain and range of this one, you can just flip it to find the inverse. Okay, that's your FRQ tomorrow. Got it? All right, last one. Similar question, believe it or not. Exponential function, but instead of a graph, it's a table of values. First question is to find the end behavior. So let's do that. The limit of f of x. And I'm going to do, it doesn't matter if you do right or left first. I know to grade it according to whatever you put here. X approaches, let's do the right. As x gets bigger without bound, there's nothing stopping it from getting bigger, so we're approaching infinity. And my y values also are increasing without bound, right? Bigger on both of those. So my right end behavior would be that. Your left end behavior. Well, as we go, let's look at our x's first. You have to look at x's and y's. X's are getting smaller, right? Without a bound, nothing stopping it. X's are getting smaller. What are the y's doing? Approaching what number? 3, right? You can almost feel like the brakes are getting put on. As we get closer to 3, it's like slowing down. So that's my limit statements. What's the value of k? Well, they called it C in the last problem, but it doesn't matter what the name of it is. Call it George, I like to say. It doesn't matter what we call that. Where this number stands in relation to all the others means it's the number that takes it up or down. It's your vertical translation. So think about it. Again, we just went over this. An exponential function looks like a j in the parent function. This one, as it goes to the left, is approaching 3, so it goes like this, right? So that means k is 3. You get your point for just knowing that. Giving a reason is to get the full credit. Just like the last problem, one of two things. You can say because y equals 3 is the horizontal asymptote, or you could give me this limit statement again, because that limit statement is telling us there's a horizontal asymptote at 3. One or the other would get you the full credit as your reason. Okay? Here it's telling us b is 2. How do we know? Well, to give the reason, we're going to talk about the x's and the y's. And we had an example similar to this in our homework once. And I said, let's just look at the nice numbers. There's enough here. I can find a pattern. I can ignore the decimal ones and make my life a little bit easier. So what's happening here with my x's is I'm adding 1, right? X's are increasing by 1. And look what my y values are doing. In a typical exponential function, one that doesn't have h's and k, you would see multiplication, times 2, times 2, times 2, or times 3, or times 5, or whatever. But here, it's hidden under another pattern that we've seen a bunch of times at this point, not a bunch, but a few. So when you see that happening, that means that there's a transformation going on in our exponential function, which we already knew. There was the h's and k's in there. And what those numbers are, sorry, I shouldn't have written right there. What those numbers are being raised to 2 to the power of n, meaning n can be any number, any number. So if I put a 0 in for n, 2 to the 0 power would give me this 1. 2 to the first power would give me 2. 2 to the second power would give me 4. So it's in there, base 2. It's just hiding under a layer of h and k stuff happening. Okay? So they already told us. We should be able to have said b is 2, but now we know, okay, b is 2. They gave it to us. The y of it is because the x values are increasing by 1, and the y values are increasing by powers of 2 to the n. Okay, so to get full credit on this one, you want to talk about your x values, you want to talk about your y values. Okay. Okay, so looking at our function, they want us to find the value of h. We already have b, right? We know b is 2. We know k is 3. We already found those. What they want is h. And then once we find h, write the equation for the function. Well, what's nice about this problem versus the one we just did is there are 5 variables, f of x, b, x, h, and k, 5 variables. We actually have 4 of them. In this problem, you can pick any x and y here, and then plug those 2 along with b and k, and just solve for h. You only have to do it one time with this one. So pick any point. It doesn't matter. We don't need the one with the 0 in it because we have enough letters. I just picked the 4, 4 point, but it really makes no difference. You could use any point, okay? And I'm going to plug in y equals b to the power of 4 for x minus h plus 3. And I'm solving for h here. So when in doubt, get your base by itself. And there's really 3 different ways you could solve this. You could use your graphing calculator. I just showed you how to solve an equation like this. You could use your intersection. You could rewrite it in log form. Or the easiest way, in my opinion, is to get like bases. If you can get like bases, the problem's pretty fast. And believe it or not, we can make a 1 into a 2 because 1 is the same as 2 to the 0 power. Right? Any number to the power of 0 is 1. So I just replaced 1 with 2 to the 0 power. Once your bases equal each other, you can set your exponents equal to each other. So I would have 0 equals 4 minus h and solve for h. And I would get h is 4. Write the equation. F of x equals b to the x minus h plus k. Again, never plugging anything in for x and y in your final answer. Inverse. Switch x and y, solve for y. So this is an exponential. The inverse will be a log, just like we did in the last FRQ. We had to do the same exact thing. Get your base by itself, subtracting 3. And write it in log form. To write something in log form, you start by writing the word log. Since our base is a number, we use log. If the base had been an e, we would have used natural log. The exponent gets its own side of the equation. And the x minus 3 in parentheses for full credit. And then one more step to get y by itself would be plus 4. So my final answer would be log base 2 in parentheses x minus 3 plus 4. And graphing them both on the same grid, the points are right here. Don't waste time with your calculator. Graph some points. Don't forget about your asymptote. So for f of x, the original function, don't forget you would have a horizontal asymptote at 3, and then some points. Label it. How do you find the inverses graph? Flip the points, right? The inverse would be this XY chart flipped. But also don't forget this. If there is a horizontal asymptote at y equals 3 for our exponential, then we will have a vertical asymptote at x equals 3 for the log. So y equals 3, switch x and y, x equals 3. So 3, 3, and there's the inverted points of that. Make sure you label. I want to know which one is f of x, which one is the inverse to get full credit, okay? It's a lot. It's a lot. That's why I gave us 3 days. Gave you some really good hints there. There's a few minutes. Is there anything in 1 through 6 that anybody wants me to go over? 1 through 6? 1 through 6? Mm-hmm. Sure thing. What else? What else did I miss? Number 5, you said?
Yeah.
Okay, so they're giving you f of x, and they're giving you at the inverse is 7. So look, we have seen this for a million years, right? F of x. The minute that inverse thing that goes there, you switch. That's now 7. So I would have, so y is 7, and I'm just going to solve the equation.
Okay.
Plus 1. You got it now?
Yeah.
And then the cube root, math 4. Oh, this is not calculator portion, so you would have to know. 2 times 2 times 2.
Yeah, because I thought like what you were doing was like since the 7 was in like the X spot on there, with like the F and -1 was, I thought you were plugging in 7 for X on the equation.
Yeah.
Yeah.
Like this.
Yeah, I get that.
Good. Good, good, good.